Good morning, my dear students. So today in this class we shall deal with remainder theorem. In the last class we have completed the exercise. So today we shall deal with the remainder theorem. Then what is remainder theorem? So the statement states that let p of x be any polynomial of degree greater than or equal to 1. So greater than or equal to 1 means it might be a linear polynomial or it might be a quadratic polynomial. So if p of x it is greater than or equal to 1 and let a be any real number. Let a be any real number. If p of x is divided by a linear polynomial x minus a. So as we are seeing, it is a linear polynomial whose highest order is equal to 1. So if p of x is divided by a linear polynomial x minus a, then remainder is p of a. If at all it is divided by the linear polynomial x minus a, then the remainder is p of a. Or if it is divided by a linear polynomial x minus b, then the remainder will be p of b. So hope you are getting what I am telling. Okay? Let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number. If p of x is divided by a linear polynomial x minus a, then the remainder is p of a. So then how to prove this? When p of x is divided by x minus a, the quotient is q of x, obviously, right? The quotient is q of x and the remainder is r of x. And in your lower classes, you have already come across dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. That is, p of x is equal to x minus a into q of x plus r of x. R of x is nothing but the remainder. Q of x is nothing but the quotient. So x minus is nothing but the divisor. So dividend is equal to divisor into quotient plus remainder. So in the next step, what we have done is p of x is equal to x minus a into q of x plus r. Why it is r instead of r of x? Why is r of x is a constant? Because r of x is a constant, it is equal to r. If x is equal to a, so the linear polynomial what we have taken x minus a. Okay, so x minus a, if you equate this to 0, x will be equal to what? X is equal to a. So if at all you are having a linear polynomial like x minus b is equal to 0, x will be equal to what? X is equal to b. Suppose you are having a linear polynomial like x minus 6 is equal to 0, then what will be the x? X value will be equal to 6. Okay, so if x is equal to a, then p of a in place of x, you are supposed to replace it by a. Then p of a is equal to a minus a into q of a plus r. A minus a, it is nothing but 0. 0 into any term, it is 0 plus r. So therefore p of a is equal to r, which is nothing but the remainder. So once if you go for using this remainder theorem, the first thing is you got to equate this polynomial to 0. If you are going to equate that linear polynomial to 0, whatever the value you are supposed to get, it should be substituted wherever you are having the variable. So then after substituting, once you get the answer, that will be your solution, that will be your remainder. Okay, hope you have got this concept. So let me move on to the problems. So let me move on to the exercise 2.3. So find the remainder. So the question is find the remainder. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Is divided by a linear polynomial x plus 1. Okay, so this is the question. So now, suppose in the question he will ask you to verify with the help of remainder theorem. First thing is you got to go by long division method and then you are supposed to verify. So now I will show you both the methods, long division method as well as the remainder theorem verification. Okay, so now if we start dividing, x plus 1 x cube plus 3x square plus 3x plus 1. Okay, so here I am having first term as x. Here I am having x cube. So in order to get x cube, what I should multiply? You are supposed to multiply by x to the power of 2. So x to the power of 2 into x, it is x to the power of 3. Then plus x square into 1 is 1x square. Now you know how to subtract, change the signs. Minus, as it is plus it becomes minus, as it is plus here it becomes minus. So these two gets cancelled. So unlike signs to be subtracted, it becomes plus 2x square plus 3x. Okay, so here I am having x, here I am having 2x square. What I should multiply? I am supposed to multiply with plus 2x. So that I will be getting 2x square plus 1 into 2x, it is plus 2x. Again change the sign. These two gets cancelled. 3 plus 2, so 3 minus 2 it is plus 1x. Then bring this plus 1 down. So here also I am having x plus 1, here also I am having x plus 1. I should multiply by plus 1. So 1x plus 1. Change the sign. Remainder is 0. So this is the answer you got by long division method. Now let me check or verify it by remainder theorem. So by remainder theorem. So what is the remainder theorem? Equate p of x as 0, that is x plus 1. One second. Equate this x plus 1 to 0. X is equal to what? Minus 1. Now substitute this x equals to minus 1 in the given polynomial. So equation is p of x is equal to x cube plus 3x square plus 3x plus 1. So x value is what? X value is minus 1 is equal to minus 1 cube plus 3 into minus 1 whole square plus 3 into minus 1 plus 1. As I have said in your lower classes, as the number is carrying minus sign, if the power is odd, minus retains as it is. So this is minus 1. So minus 1 the whole square, square even number, it becomes plus 3. Then minus 3 plus 1. Plus 3 minus 3 plus 1 minus 1 cancels, answer is 0. So this is how you got to verify with the help of remainder theorem. Okay? So just apply the remainder theorem, go for finding the values. For your verification or else for your extra information, I have shown you with the help of long division method as well as with the help of remainder theorem. Next, the second main question is find the remainder when x cube minus ax square plus 6x minus a. 6x minus a is divided by x minus a. Divided by x minus a. Simple. X minus a is equal to 0. Then x is equal to what? X is equal to a. Okay. So p of x is equal to x cube minus ax square plus 6x minus a. So x is equal to a. P of a is equal to a cube minus a into a square plus 6 into a minus a. So now a cube, a square, bases are same, powers plus we added, minus a cube plus 6a minus a. Unlike signs gets cancelled. So 6a minus 5a, it is, sorry, 6a minus 1a, it is 5a. So 5a is the remainder for the polynomial x cube minus ax square plus 6x minus a. Okay. Next, the third main is So the third one is check whether 7 plus 3x 7 plus 3x is a factor of 3x cube is a factor of 3x cube plus 7x. So here I got to check whether 7 plus 3x is a factor of 3x cube plus 7x. Then how to check? Please remember, if at all the remainder is 0, if you get the remainder as 0, then it is a factor. If the remainder is not 0, then it is not a factor. So this is how we are going to check. So now 3x plus 7 is equal to 0. So 3x is equal to what? Minus 7. X is equal to what? Minus 7 upon 3. Okay. So now I got to substitute this value in the given polynomial. So P of x is equal to 3x cube plus 7x. So 3 into minus 7 by 3d whole cube plus 7 into minus 7 by 3. Okay, so now it is 3 into so 3 into minus 7d whole cube, as the power is odd, minus remains as it is 343 divided by 27 plus 7 sevens are 49 plus into minus minus upon 3. Now 3 ones are 3 nines are. I can go for cancelling. So now it is minus 343 divided by 9 minus 49 by 3. So if I want to take the LCM, 9 will be my LCM. So minus 343 minus 3 are 3 9s are 27, 3 4s are 12, 13, 14. So this becomes minus 343 minus 147. It is minus 490 by 9. Children, here I have not got the remainder as 0. Instead, I have got the remainder as minus 490 by 9. So therefore, 7 plus 3x is not a factor of 3x cube plus 7x. Okay? So hope you all are clear with the remainder theorem. So the next one will be our factor theorem, so which I am going to deal with the next video. Thank you.